Today's problem is make strings equal difficulty medium. Let's see. You are given two strings, S and T, consisting of lowercase English letters. You are also given a 2D array transform where each entry, X, Y, so it's an array of two-element arrays, each element being a lowercase letter, meaning that you are allowed to transform character X into character Y. You're also given an array cost, where cost at I is the cost of transform I0 to transform I1. We'll look at an example of this. You can apply any transformation any number of times on either string. Your task is to find the minimum total cost required to make the strings identical. If it's impossible to make the two strings identical, using the available transformations, return -1. All right. So let's look at a couple examples. Let's see. We have ABCC and BCCC. Here are the available transforms. Here are the corresponding costs of the available transforms. So we can transform A in S into B. We can transform the B in S into a C, and then both strings would be B, C, C, C. The cost of that would be A to B is 2, B to C is 1, total cost is 3. Let's try the next one. Transform A to AZ to DC. Okay, the only transform we have for Z is we can transform it to C at a cost of 10. We can also transform A to D at a cost of 50, but that's an interesting aspect of this problem, which is that shortest paths. Well, yeah, we've done some Dijkstra problems. This is like a Floyd Warshall problem, where the Floyd Warshall algorithm is an all pairs shortest path algorithm. So Dijkstra is single source. It'll give you the shortest path from some source vertex to every other vertex. Floyd Warshall will give you the shortest path from any vertex to any other vertex. So that's useful because A to D at a cost of 50 is not as good as A to B and then B to C and then C to D, which would be a cumulative cost of 5 plus 3 plus 2 is 10. So 10 plus 10, 20. This one you can look at it, but there's no way to do the transform. Okay, size. Size is less between 1 and 10 to the 5th, which is 100,000. Transform size will be equal to cost size, and that will be between 1 and 500. The elements in transform will be lowercase letters from A to Z, and cost will be somewhere between 1 and 500. Okay, expected complexities. These are a little bit misleading. Okay. Floyd Warshall is O of V cubed. All right. Now, you're going to see in here that this here is basically the Floyd Warshall algorithm. And the reason that it's O of V cubed is because we have a 3-level nested loop. But because in this case, no matter what the length of the strings is, this loop is always going to go from, these loops are always going to go from 0 to 26. So you can say, well, that is a constant time algorithm, right? Even though it's going to be a big number, 26 squared, well, let's see, 25 squared is 625 times 25 is 6,000, 12,000. Okay. Now, yeah, you could say, all right, that's constant time, but still, this part down here, where we run a loop over the length of the strings, is O of n. And n here could be up to 100,000. 26 cubed is less than 100,000. So that's why you get to say, well, the complexity is O of n, even though you've got a 3-level nested loop in here. You can also say auxiliary space is O of 1, constant space. And again, that's right, although we do need a 26 by 26 matrix. But, you know, that's what we need regardless of how long the string is. So, all right, constant space. We're passing off a V cubed algorithm as linear O of n. So it's easy to look at that and get off on the wrong track. So this would be a kind of a good thing to absorb, and that is that when you're dealing with a constant like number of letters in the alphabet, you can always say that that is constant time or constant space. So anyway, let's look at the algorithm. Let's see. All right, we need a big number because we're looking for minimum costs. We need to initialize some things as a big number so that the first cost that we obtain, or distance, I guess we could say, distance? I guess we're calling it distance in this case. So the first distance that we obtain will be less than this number. All right, so we've got a distance matrix, and it's 26 by 26. It associates every letter of the alphabet with every letter of the alphabet. Now, for letters that are the same, like when I equals J, the distance is going to be 0. That's like, you know, distance from A to A or B to B. But the initialization of any letter to any different letter is going to be max. Okay, there's our distance array. Now we supplement that with what we can get from the cost array. So we go through the transform. We get the 2 letters. We convert those into indices from 0 to 25 by subtracting the lowercase letter a, and then in the distance matrix, we're going to say, well, the distance is, you know, we probably don't even need a math min here at this point, but the distance is going to be whatever is in the transform array. All right, so we're ready to go here at this point. And the way Floyd Warshall works is it's going to compare every combination of letters, I, J, and K. And it's going to check to see if the distance that we currently have from I to J is, if we can improve on that by going to some intermediate vertex. Like instead of going from I to J, maybe there's a shorter path if we go from I to K and then K to J. So every combination of letters, every combination of 3 letters, we're going to iterate through that and arrive at the best path from I to J. Not, I guess you could say the shortest path, but we're talking shortest in terms of cost, not shortest in terms of like this one. Let me move it back over here again. Like this one, going from A to D. You can go straight from A to D, but it's very expensive. On the other hand, you can go from A to B, B to C, C to D. More steps, but it's cheaper, all right? And that's what we want. All right, now we've got the matrix, we've got the shortest path from every letter to every other letter. And we iterate through the 2 strings, S and T, all right? So starting with I at 0 and iterating through the strings, we get the letter from S and we get the corresponding letter from T. We convert those to numbers from 0 to 25 by subtracting a lowercase a. If the letters are equal, then we don't do anything. There's no cost if the letters are the same. Otherwise, we're going to set best to max, and we're going to iterate through all the letters of the alphabet. We're going to see if there's a path from A to C and there's a path from B to C, and if the combined cost of transforming A to C and B to C is lower than whatever we have in best right now. Now, there's not keeping in mind that there's not a requirement that we transform A to B. There's just a requirement that we transform A and B. Well, in this case, A and B to the same letter, which we're calling C. All right, so that's one option, is transforming them to the same letter. Now, the other possibility is, because C is iterating through all 26 letters, that at some point C is going to be equal to A, and at some point C is going to be equal to B. So at that point, we're going to get the cost of transforming, A to B or B to A. We would have like distance from A to B plus the distance from B to B. Now, distance from B to B is 0, so it's just the distance from A to B. All right, so this finds us the best transformation of the letters in S and T at a corresponding index if best equals max. That means we were not able to find a transform. Then nothing happened here, and we're going to have to return -1. Now, if we were able to find a transform, we'll take the cost of the transform added to total. When we're done with the whole thing, we'll return total. All right, so let's try to run this. Okay, let's see. So again, the core algorithm here is called Floyd Warshall. It's an all pairs shortest path algorithm, which is really what we want here. We want the distance from each letter to every other letter. We need that because we need to be able to determine if something like going from A to D at a cost of 50 is better than going from A to B and B to C and C to D. And unless we have the cost of each pair of of going from between each pair of letters, or the knowledge that there is no way to go between a certain pair of letters, and we can't do that. So, all right, that's it. So please like the video, subscribe to the channel, and that's it. We'll see you next time.